so we're going to do polynomial and rational inequalities. So what's a polynomial again? It's a polynomial. X to whole number non-negative powers. What's rational? Fraction. Good. So we know what we're dealing with. Inequalities. Okay, so polynomial inequalities, the steps to solving polynomial inequalities. First, we set the inequality so that 0 is on one side. Then we solve the inequality as usual. We're going to set it equal to 0 and solve it is what we're going to do. Then we're going to set up a table with the values from step 2. Choose test values in between those values we get from step 2 and determine the solution. So let's do this. So number 1, x minus 3 times x plus 2. So how do I solve this? What? No. Huh? Okay, so let me do the first one then. Set them both equal to 0. So I'm going to say x minus 3 times x plus 2 equals 0, right? This is a quadratic equation. If I solve it, I get x squared. The way to solve, the two ways we know to solve quadratic equations: 1, factor; 2, quadratic formula. So I already have it factored. Don't FOIL it. Then you'd have to undo it. Right? It's already factored. So I get x minus 3 equals 0. X plus 2 equals 0, so I add 3 to both sides. I end up with x equals 3 and x equals negative 2. Okay, so that's step 2. Solve it as usual. Now I need to set up a table with values from step 2. Here's my table. Okay, so set up a table with values from step 2. Did it. Huh?
How can we do something like this? Like the open circle, closed circle, and
something like this. So we did like different things in interval notation.
Yeah, that's good.
Okay. So then we need to choose test values in between the interval, in between each value. So I'm going in between here. I'm writing it in different color to indicate that those are my test values. The black is the solutions that I got from solving. These are test values. So what's a test value over here? Negative 3. What's the test value in here? Always go 0 if you can. 0 is the easiest, right? Here's a value of 4. Okay, so now I'm going to plug in 4 into my equation and see if it's positive or negative, because I want it to be greater than 0. I don't care what the number is. I just care if it's positive or negative. So if I plug 4 in, 4 minus 3, that's positive 1. 4 plus 2, that's positive. Positive times positive is positive. I only care about the signs, because for my test value, maybe I chose 4. Maybe Joe chose 10. I don't know. You could choose whatever you want to choose as long as it's in this interval. This interval is 3 to infinity, right? I might choose something different that you choose. The value that you get is not important. The sign is what's important, because we're getting 0 on one side. We only care if it's positive or if it's negative. Okay, if I plug in 0, I get negative 3. If I plug in 0 here, I get positive 2. Negative times positive is negative. Okay, if I plug in negative 3, this is negative, this is negative. Negative times negative is positive. Is it clear what I'm doing? Okay. So I got these values by solving. Then I chose values in between, and I'm plugging those back into the original to see what the sign is. So if I plug 4 in here, I get 4 minus 3. That's a positive number. If I plug 4 in here, I get 4 plus 2. That's positive. Positive number times a positive number is positive. So I'm writing that down. If I plug in 0, 0 minus 3 is negative. 0 plus 2 is positive. Negative times positive is negative. I put negatives here. Same thing with x equals, same things with negative 3. Now I'm saying, okay, I want to know when this is greater than or equal to 0. So I want it to be positive, right? So I don't want this section because that's negative. I want these. So I need to write these two intervals. Negative infinity to negative 2, union 3 to infinity. Somebody help me with my brackets. Open brackets, close brackets. What do you guys think?
Close.
Why? Because it's or equals to. So it's a hard bracket. That's my answer. So let's think. You guys said that this is quadratic, right? What does a quadratic equation look like on the graph? Parabola, right? Parabola. Okay? What's the lead coefficient of this quadratic equation? It's 1, because I get x squared, right? So I have a positive lead coefficient of an even polynomial. It looks like this, right? If I get 2 roots, this is what I get. If I have 2 roots, it looks like this, right? Graphically, that's how it looks. So I found the interval when it's greater than 0, when it's positive. Where is that here? It's when it's above the x-axis, right? It's when my y values are positive because f of x equals y. So I'm looking at when I have positive y values, right? Okay, so I just told you how to check your answer on your calculator. Did you guys all hear it, though? I graph my function. Y, go to the y equals. Graph it. If you want it to be greater than 0, you're looking at where it's above the x-axis. You can see that once you graph it, right? You can also use your knowledge of quadratic equations for all of these, right? Lead coefficients, degree of the polynomial. You can tell with end behavior what you're going to have, right? Does that make sense? Quadratic. So if I had a negative coefficient, negative lead coefficient, it would be facing down. Right? So if you ever have a positive coefficient, it's going to be negative in the middle, positive on the ends, right? If it's the other way, it's going to be positive in the middle, right? Facing down. It's going to be positive in the middle somewhere and negative at the ends. So make sure whatever you get is making sense with your knowledge about what we've done and behavior and coefficient stuff. Okay? All right, let's do number 2. I think you guys can start it on your own. You're setting it equal to 0 and solving. Somebody help me factor. X minus 1, x minus 3. Thank you. So I get x equals 1, x equals 3. Put that on the number line. What are some test values you can choose? What? I always like to choose 0. Got to choose 2 in here. Maybe somebody wants to have a little fun and choose 2.5. Go for it. Make it easy. You can choose any test value you want. Here, I'm going to choose 4. Maybe you want to choose 100. I don't know what you do for fun. Somebody have a question over here? No? Okay, so now I'm taking these test values and I'm plugging them back into the original. If I plug 4 in, I'm going to plug it back into the factored.
That's what I was going to ask. Can you plug it into the factored version?
Yeah, I'm going to plug it into the factored because it's easier to see, right? If I plug 4 in here, I might have to get my calculator out. If I plug 4 in here, I'm just looking at the sign. So that's easier to me. So 4 minus 3, or 4 minus 1 is 3, positive. 4 minus 3 is 1. Positive times positive is positive. Okay, 2. I plug 2 in here. That's positive. I plug 2 in here. That's negative. Positive times negative is negative. Plug in 0. That's negative. Negative. Negative times negative is positive. Again, this makes sense with our idea of graphs, right? The only thing I would need to do to change this picture is to change my x-intercepts. But it's still a parabola opening up. Okay, so I want when it's less than 0. That means it's negative. So I want this. Hard bracket because it's or equals to. You guys feel okay about this? Okay, I don't want to do 3. It's boring. What do you guys think about 4? X squared, so it's going to be a parabola. Negative lead coefficient means it's opening down. You want when it's greater than 0, right? So that's going to be the ends. So think about that. Do the steps that we just did, but think about that and think about how that's a way to check your work. So you guys do this one on your own. Number 3, what's the only thing you need to do before you can do number 3? Good. Get 0 on one side. So you'd subtract 1 from both sides, and then you could do the exact same steps. So you guys do 4 same steps. What kind of an equation is this that I have? What is it? It's quadratic, right? I have x squared. So quadratic means I either factor it or do the quadratic equation, quadratic formula. Those are the 2 ways we know how to do it. Did I get it right? Yeah? Were you guys able to get it on your own? Good? What do you think, Morgan? Okay, number 5. What degree is number 5? The third. If you multiply x times x times x, that's x to the third. I already have it factored, so it's super easy. So you guys can do it on your own too. So without doing this table, what do you guys think about this? Let's draw our picture from our knowledge of drawing graphs. This is cubic, right? Odd degree, positive lead coefficient. So what does that mean? Odd degree means opposite ways, right? Lead coefficient is positive, so that means something like this, right? My roots, or my zeros, are 1, 2, and 3. So I need to connect the dots now, right? So when is it positive? Well, we're looking at when it's negative. So it's negative over here and it's negative here, right? Use your knowledge. Use your understanding. Right? Each of these are multiplicity 1. Each of the roots have the first power. So because they have the first power, they cross, right? If it's an even power, if I would have had something squared, then it would just touch. All right, so now put it in the table. So use this knowledge, but also, let's make sure we're showing the proper steps. Good? You guys want to do 6? Or are you good? You guys good with, you have enough examples? I think that's enough examples. I can write the rest out and scan them if you guys want, but it's the same exact process, right? Number 6, you're just going to have to factor. How are you going to factor this? Factor by grouping. Good. Then you're going to get to something like this, and then it's the exact same process. All right, so let's do rational inequalities. What does rational mean again? Somebody told me? Fractions. So I have fractions. So solving rational inequalities. First, we get 0 on one side, just like before. Then we set the numerator and denominator equal to 0 separately. So that's the only new thing. Then we set up a table exactly as before. Then we choose test values exactly as before. Then we determine the solution. So the only thing that's really new here is setting the numerator and denominator equal to 0. What happens if we set the denominator equal to 0 again? The denominator of a fraction equals 0. What does that mean about the graph? Huh? Asymptote. Good. Vertical asymptote. Okay, so here I have something factored over something factored is greater than or equal to 0. Good. Don't really need to do much. Just set the numerator equal to 0. Set the denominator equal to 0. And I get x equals 4, x equals negative 3. All right, let's set up that chart. Negative 3, 4. Choose some test values, plug them in. Okay, I'm going to plug negative 4 in here. Negative 4 in the numerator makes it negative. Negative 4 in the denominator is negative 1. So I have negative divided by negative, that's positive. If I plug in 0, I get negative 4 over 3. Negative divided by positive is negative. Bless you. If I plug in 5, 5 minus 4 is 1. That's positive. 5 plus 3, that's 8. That's positive. Positive divided by positive is positive. Okay, so I want when this is greater than or equal to 0. I want when it's positive, right? All right, so think about your interval notation. Think about it. Think about it again and see if it makes sense. And then I want somebody who's really thought about it to tell me interval notation. Anybody get anything different? Why did I say think about it 3 times if it was just that? Amelia, what do you think? Why does negative 3 need a soft bracket? It's a vertical asymptote. So negative 3 is not in the domain of the function. So even though there is an or equals to, if I get 0 in the denominator, that's not allowed. So around negative 3 needs to be a soft bracket. And that's because negative 3 is not in the domain of this function. Right? Good. All right. You guys want to try number 8 on your own? Number 8 is exactly like number 7. So you guys try it on your own. I'll try it on my own. Somebody make sure I can add. Oh. Did I get it right? No? I think I got it right. Okay, so I'm looking for when it's less than 0. So I don't want the positive. I want this. I like to put a little circle around the x value that's not in the domain. Whether it's less than or equal to or just less than, doesn't matter. But that reminds me it's a soft bracket. Okay, so I have negative infinity to negative 5 over 3 union 3 to infinity. And they're both soft brackets because of the less than. So 3 is not in the domain because it's the denominator equals 0. Same thing here. Right? You set the numerator and denominator equal to 0. Wherever the denominator equals 0, it's not included no matter what. That's why you have one soft bracket, one hard bracket here. Good? I can't hear you. What about it? Okay. Tyler, I appreciate your questions. Tyler is always engaged. He's always paying attention, and he's always working hard. If Tyler wants to ask a question, he can ask a question anytime he wants to. That's for you, Joe. Tyler already knows he's a good student. Okay, ready? So, how many more y'all want to do, y'all? I think we should do either 10. Okay, so you see number 9 is very similar. You see 12 is very similar. The only reason 9 is a little different is because I'm going to have 3 values. Number 10 and 11 are different though, right? So let's do at least one of those. All right, let's do 10. So I need 0 on one side, right? I need to add or subtract fractions. How do I do that? Common denominator. So let me move this over a little bit. So what's my least common denominator? X minus 3. So I'm going to multiply this by x minus 3 over x minus 3. Okay, so I have 1 over x minus 3 minus x minus 3 over x minus 3. Okay. Now I need to subtract those fractions. 1 minus x minus 3 over x minus 3. All right. Made the mistake. What is it? No parentheses. Whatever you're subtracting, you need parentheses around that. I'm subtracting this whole fraction, not just part of it. Okay, so now I'm going to distribute. Now I'm going to combine my like terms. 4 minus x over x minus 3. And now I'm at a similar spot to the previous problems. But I had to get 0 on one side, and I had to add and subtract fractions. What do you think, Parker?
Well, now we can just do what we did before. Right?
Is everything here good? Sometimes I can't tell if you guys in the back are like squinting because you can't see or squinting because you're not sure. Okay. Good. Now we just do the same thing we did before. So let's do that again with number 11. I think you guys can finish it from here. Let's do the same adding and subtracting fractions with number 11. All right, so I'm going to subtract 2 from both sides. Now I need to add and subtract fractions. What's my common denominator? That's correct, x plus 2. Okay, so now distribute. I'm going to put it over the same denominator to save a little space. Oops. Am I right so far? Yes? x minus 2 minus 2x minus 4 over x plus 2. Now combine like terms. Now same exact thing as before. So I'll finish this one up. Yes. Okay, so I'm going to set the numerator equal to 0, and I'm going to set the denominator equal to 0. I'm going to put my values on here. And notice again, I'm using my test values in a different color. My test values never appear in my intervals. Only the values I got from the solving are what appears. So that's the part where I'm making sure I use a different color to try to stay organized. So somebody help me out. What if I plug in negative 3? Negative 3 in the numerator is what is it? It's negative in the numerator. Negative 3 in the denominator is negative. Negative divided by negative is positive, right? Is that correct? Okay. What about negative 7? Negative? Okay, so we want when it's, and I'm going down to here, we want when it's less than 0, right? So we want that negative part. Which value is not in my domain? Is it negative 6 or negative 2? All right, so keep that in mind when you're making your intervals. Good? Does it make sense? So it's just solve them like we have been, but then do the little test value. All right, so now we have enough time for a quiz. Okay, so put your notebooks away. It's going to be closed. Take out a piece of paper. Okay, put your notes away. It's closed notes.